starting now. So welcome all to the second of this series of webinars on the results of task 36, IEA Wind TCP task 36 for forecasting of wind power. And on the program today, we have Corinna Möhrlen from WEPROG, Jeff Lerner of Vaisala, and John Zack of UL, the former AWS True Power. If you are not part of the speakers, then please mute your microphone, as we will only have one speaker per time. And we will have a different system for questions, which is this Slido system. You go to sli.do, as you see here. You type in the code U719, and then you can ask questions and also make questions a bit more popular. So we'll take them from the top, the highest ranking questions first. And after having said that, I'd like to give the word to Corinna Möhrlen for the first part of this talk.
Thank you, Gregor. I hope everybody can hear me. And for some, it's morning, so good morning. For others, it's afternoon or starting evening, so hello, everybody. This webinar is, as Gregor said, about a recommended practice, and there has been a group of about 10-15 people that have been working on this over the last 1.5 to 2 years, almost for 2 years ago we started to discuss, and then we started the real work for 1.5 years ago. And the aim is clear. We want to develop a recommended practice, and what our objective was is to have a guidance for the implementation of renewable energy forecasting into system operations. This is what we defined as our goal. And when we started to discuss how we can achieve this goal, we found 3 parts, or we identified 3 parts where we think it will be useful for the industry to get some guidance and some reference. And that was the selection of an optimal forecasting solution, the design and execution of benchmarks and trials, and the evaluation of forecast and forecast solutions. So in a way, it started with a discussion about benchmarks and trials, and then we realized, but you know, the benchmarks and trials, this is something that has a purpose, and this is usually to select a forecast solution. And then one of the strongest or the most important things about benchmarks and trials, this is how to evaluate them. And so these 3 parts have started, and you can follow the task. They are on our webpage, and the guidelines will be online, and once they can get published, I hope we'll get there in the first half year of next 2019. And there are a number of already some publications that you can have a look at that demonstrates the work that we have been doing. So Gregor, can you, okay, we can move forward. So I will be now talking quickly about the forecasting solution selection process. And what is most important about this is that we have to establish a requirement list. The requirement list is something that is often underestimated, how important this is. And by requirement list, I really mean that that there has to be a vision about where do we want to be when we're done with either a trial or RFP and the solution selection, and to do this, to get this, we need to really analyze the current situation. and obtain input from forecast vendors and list all sorts of organizational and statutory requirements. And what we have seen throughout our discussions with our own experience as forecast providers, but also when discussing with end users, is that sometimes a solution is designed without taking into account what can happen along the way and how is the statutory requirements, how is this situation maybe changing within the next 1, 2, 3, 5 years, and how do I have to build up my system and my forecasting tool so that it still is in a way flexible, but it's not getting so large, or so flexible that it's becoming a too large effort. So these are the kind of things that are important to go into detail, to really outline where do you want to go, where do you want to, where does the path go, and then we said, okay, in a way, sometimes we as forecast providers miss to be engaged in such processes, and it's not because we want to influence, as everybody wants to maybe influence, but it's more that often you have an idea how things evolve and experience that the end user doesn't have, and by collecting such experience, it helps to define these goals and make this requirement list. So by asking specific questions and ask forecasters to provide information and insights from their experience, and also from other jurisdictions. Sometimes it's difficult, sometimes there are end users that you know of, but other times you may not. And so it's always important to engage others and also engage the forecast providers. Next slide, please. So when we looked at the main parts of the requirement list, then one of the first points that we realized is often also highly underestimated is the IT infrastructure. The IT infrastructure is what we call the alpha and omega in every real-time system and forecasting system that we have to look into. Where do we want to go? How does a system evolve? How much data do I collect? Could I maybe collect more data in a year's time or as things evolve? And so the infrastructure is really important. The forecast attributes and available methodologies are, of course, what the core of the system will be. But then also the support and service, that's sometimes not so easy to define, but it's important to really think about it before you go ahead. And then performance specifications and incentives, that's also something, how do I ensure that the forecaster or the forecasters keep their performance, keep on doing good work, and how can I incentivize them? But also for myself, what is important for myself so the forecasters know where they have to improve or work on. And then, of course, the contracting terms. And sometimes it's difficult. There are other aspects like short-term interim solution. If this is the goal, there are some other points that have to be looked into, or if it's a long-term solution, then there are different departments that have to be involved, and there has to be analysis of statutory requirements and maybe also a pilot. Sometimes it could be used as an interim solution or so. So there are, of course, different aspects, and we will go into in the guideline more into detail about that. Next slide, please. So coming back to the IT infrastructure, I have put some such a group of people that are discussing and about the infrastructure, how do we build that up, and how do we work out the most crucial points, like, one says, what if the market requirements change? Can the solution be changed and developed along the way? So this is something that we have to ask. Or databases, that is, the database structure is one of the most crucial points of the IT infrastructure. Are they prone to have limitations? How difficult and how expensive is it if I have to expand? So choosing the right database structure is a very important thing. Sometimes you can get a good start, but then making it larger can become extremely or exponentially more expensive. Then sometimes we have heard also examples where the database in itself is not that expensive, but the support about it or getting help may be a challenge afterwards. So these are things that really have to go into such considerations, and data storage and historical data accessibility. I have heard end users telling me that I would like to do some analysis, but it takes me a month to extract 1 year of data from our database. It's practically impossible. And that's something that needs to be considered. How important is it to do analysis? How is the database structured so that if different departments need to do different analysis with historical data, how do I get hold of this, and how can I build that up so that there is access to these kind of things? And then, of course, how can I use it to verify and evaluate forecasts? Okay, next slide, please. And the infrastructure is, of course, also has a lot to do with the way I build up my system, whether I use a single or multiple vendor solution. And here we have just tried to put some pros and cons on the vendor solutions, because sometimes it seems like, multiple vendor solutions, this is really have become popular, but it has also shown to be a quite complex infrastructure. The database requirements are quite high, and then the strategy, whether I blend or mix forecasts or use it as a primary, secondary, that is very important. It can also cause quite a lot of problems if the algorithm for the mixing requires all forecasts to be in at the right time. So what if one forecast is missing? How does that work? So there's can become quite a complicated system, and can also have higher costs. On the other hand, there is a possibility to have higher accuracy and also higher reliability. But the reliability is really something that is often underestimated or overestimated, that I have a higher reliability if I have many, but then I also have a more complex system because I have to make sure that if one is missing, my algorithm can still generate a good and accurate forecast. So that's then the opposite. If I have a single vendor solution, I have other requirements. Here are the requirements for reliability and the quality of the forecasts have to be high, but I also need to have more monitoring, and the performance has to be higher. So a single vendor solution, you have to make sure that you have a SLA that ensures you always have a forecast. On the other hand, you have less data volume than in a multiple vendor solution. The database structure is less complex, and as we go along and we can see that a lot of the forecast vendors have similar performance, then it really depends on what is what is your goal and what is the most important thing for you to achieve. Can this be achieved with a single vendor solution? Then you should definitely look into this. It's not the multiple vendor solution is at least not always the one that always gives you the higher accuracy. That depends on how the system is built up. Thanks. Next slide, please. Yes, so that's then again the same thing. If we look into the next step of when we go into the decision of whether we should have a deterministic solution or a probabilistic solution, and then there again that discussion about the multiple and single vendor solution comes in again, because a probabilistic solution with multiple vendors is very difficult, because there will be different means and methodologies, and you cannot add up probabilistic solutions. So usually it will probably be a single vendor solution if you go for a probabilistic solution, and the other way around if it's about specific accuracy on, for example, a day ahead. It has been shown that the multiple vendor solution can achieve a higher quality often, and then this is usually done with deterministic solutions. You have less information, then this is the opposite. If you have the multiple, this adds up again. So this is a pro and a con, depending on how you look upon it. And then you have maybe a reduced future compatibility. That's of course something that is still highly discussed, like in meteorology, and it's a more simple data handling. There's no doubt about this, and also less storage requirements. That's then in the probabilistic solution. We have this more complex data handling, and the storage requirements are usually also higher. But then again, you have much more information available from a probabilistic solution. So when weighing these pros and cons, it really depends on what you have defined as your goal, and how many information, how many departments or how many areas in the organization have need for the information that you can get out of the probabilistic solution. So if it's about ramping, and if it's about high-speed shutdowns, if it's about extreme events, the probabilistic solution is what you need in a way, and then you have to weigh these against other solutions or other means of what you have decided. So that's kind of what I want to tell about. I have put down a few more things there where the probabilistic forecasts are beneficial. What we have seen is that it's usually most beneficial in areas with high penetration and with high winds, because that's the complex terrain, mix of surface types, and higher risk of high-speed shutdown. And also when there is a significant variability. That's what I said with ramps and stuff. And also what we see is when there is a bad interconnection, or the control zone is not interconnected well. Okay, so let's go to the next slide. So when we look on the evaluation of a forecast, then in a tender process, then there are a few more things that we have to look upon. That's the so-called forecast attributes. Everybody kind of knows this, but it's still looking into what are the look-ahead periods that are important, and then for the look-ahead periods, I have to go back again and say what is the most important here when I go days ahead or weeks ahead or hours ahead. If it's a ramp forecast, that is most important for me, or if I have issues with congestion and high speed shutdown, then I have more different priorities, and these priorities have to, of course, be interconnected, and then also the update frequency and the time resolution. And then one of the great discussion that we have, topic that we have had and still have in some way, is the methodology. How much does the end user need to know about the methodology? And we try to find a way of educating and still bringing a kind of an awareness to what kind of methodologies fit to which applications, without being kind of teachy, to just say, well, you have to learn these things. It's not about learning about methodologies when we, what we try to do here. It's more about understanding which methodologies work with which applications. And that's still an ongoing discussion that I hope we can solve in the next couple of weeks. And then compliance to technical and contractual requirements is, of course, also something that is often underestimated. So when we look on what are these criteria when selecting a vendor or a solution, then often it has been this, it should be accurate, reliable, and it should be cheap. And that's why this is what everybody would like to have. But unfortunately, it's not that simple, because there are solution attributes, there are vendor capabilities. As I've already said, there is a vendor service structure that we have to look upon. And all these things, like the attributes, we have been talking about the deterministic and the probabilistic, single versus multiple, but then also the vendor capabilities. How easy is it for my vendor to develop with me to maintain state-of-the-art performance, and what is price versus value? What do I get out if I have an experienced vendor, or if I have a new vendor new to the market, can be equally beneficial to a solution, because there is a new look upon it. There is still ongoing development and so on. So it's really something that that should be looked upon, and the same also in the vendor service structures, escalation structures, redundancy structures, support and service structures. How well does the vendor actually fit my organization needs of communicating and getting help when operators get confused or things like that. Thanks. Next slide, please. So all that we have kind of we have developed a kind of a decision support tool that brings these things down into some condensed form, where we start with the initial plan, and then I will not go into detail now, because there Jeff and John should also get time to talk. So, but that's really what we want to what we wanted to establish, to have a kind of a decision support tool to go through in these steps and see what is the consequence of a decision along one path or another. And this is just the slide to it. And I think I will hand over to Jeff now to talk about the trials. Jeff?
All right, hello, yes. I think the host had to unmute me. Sorry about the pause there. I'm Jeff Lerner, and I'll be talking about the design and execution of benchmarks and trials. The group that contributed to the content here, if you put all of our experience together, we probably are in the hundreds of trials that we participated in. So we've had seen firsthand where trials can go wrong and some of the successful components of a trial. So we try to capture that here, so that if you were to go online, let's say our target audience here being industry, government, and even academics who will be performing a trial or benchmark. So if you were to go into Google right now and just type wind power forecast trial, you will come up with the IEA Task 36 as your #1 hit, which is great. That's what we want, because a lot of people don't even go to that length of finding, hey, have other people done this before? So like I was saying, this is best practices that are contributed from folks who are in some pretty experienced positions in companies that have been doing forecasting for a long time. So we divide into 3 phases, basically: preparation phase, an execution phase, and the post phase, like the evaluation phase, where you actually choose a forecast provider that you're going to contract with. I like to think of this in terms of, this is a long-term relationship oftentimes that the customer or the person that's running the trial or benchmark is going to go through. Once they select a vendor, forecast provider, oftentimes they're going to stick with that provider for at least a year, sometimes 5 years or even more. So it's really important that they get it right and find a provider that's going to fit with them. So oftentimes I like to say it's like price accuracy and how easy you are to work with, what it comes down to. But unfortunately in the industry, a lot of people just go with whoever has the lowest price. I'm about to buy a water heater at home. My water heater is almost 15 years old. And I looked at prices and they go from $200 to $2,000. So which one am I going to pick? I look at the $200 one and I'm like, well, yeah, that might work, but I have to consider other things. Is it energy efficient? How easy is it going to be if there's maintenance required, parts or labor? How about the fuel? What kind of fuel is it? Is there a lot of emissions from that fuel? Is it gas? Is it electric? Where's my electricity coming from? So there's all these things I'm considering, and similar with our trial and benchmark for the people who will be conducting it. So they have to consider these things. If they do not consider these things, they'll learn the hard way afterwards. So we're trying to put it out there so that people will at least have like a checklist or a reference document that they can go to and say, hey, have I thought about the forecast horizon? Do I need forecast for the same day in the next few hours? Or is it just day ahead? That's most important. That's critical, because that will have implications to the cost of running the trial and operationally receiving the forecast. If you as an operator do not have to send real-time observations to your forecast provider, there's a huge cost that's avoided. So the other thing that before you do any kind of benchmark is you have to figure out, do I have historical data that my forecast providers that are participating are going to be able to use for training their models? You know, you're trying to create a realistic scenario of what it will be like if you actually had the trial. In fact, the work should be almost identical, and the forecasts they're getting should be almost identical what they'll receive once they're contracted. So the representativeness is really important too. I can't say this enough. We've been in trial situations where people have decided, oh, well, I have more time in summer. I'm going to do a wind forecast trial in the summer. And they end up choosing the month where there might be only 2 or 3 big wind events, and they're maybe based on thunderstorms that occurred. Is that really representative? Not really. So there's all these things to consider. You know, what are the evaluation metrics? Are they important to my bottom line? Am I just going to look at the mean absolute error? Or are there things I can do, like a dead band? Let's say you can't operate outside of a certain error band. You probably want to consider that in your evaluation metrics. And John's going to go into that in a few minutes here. But actually, probably the most important aspect that people need to consider if they're going to conduct a benchmark is, how much time do I have to spend on this? And this is where we can really help out in this document, is warning people like, hey, here are the things that take a lot of time. Figure out how much time you have, and then you can figure out, well, what kind of benchmark or trial can I actually run? So I haven't decided on my water heater yet, but I'm leaning more towards the actually less energy efficient water heater that's with electric, because I'd rather use electric. And it fits where my area is that I have one right now. Okay, talking about the preparation phase, let's go to the next phase. This is during the benchmark. And I want to stress here too, if people really consider things beforehand, not rush into just running a trial, if they've done a good job preparing for it, this phase of the trial could be really easy for the person operating the trial. They're receiving forecasts and they're just accumulating data that they're going to evaluate. And if they've done a good job preparing, this part is actually fairly smooth because you already have all your transmission of data going back and forth. All the requirements have been spelled out ahead of time. So it's going to be very coming in, with the same format files. But there's always hitches that go on even in a regular subscription once you contract it with someone. So there needs to be some type of data monitoring going on. But first of all, communication. I would say that is going to be a common thread in these 4 slides that I'm presenting here, is that before, during, and after a trial, if you don't communicate as an operator to your forecast providers, it's going to create more work for you. So it's really important that communication is open and frequent and consistent. When I say consistent, I mean the same communication is done for every forecast provider. Otherwise, you might get different forecasts from one, like if a location of FTP change and you didn't communicate that to everyone, it's going to create a lot of heartache for not only the forecast providers, but for yourself as a forecast operator, a benchmark operator. So I wanted to bring up, though, during the trial or benchmark, the communication, the data monitoring, very important just to make sure things are flowing. You don't want to end a trial and realize you haven't been receiving forecasts for one or more forecast providers. Also, this is a good chance to work on scripts that are validating the results. So this is actually a time that, in my experience and others, that the forecast trial operator is developing the verification metric script. And also the reliability, and I can't say enough here, if you go with the cheapest forecast, and let's say that you're only getting it 90% of the time, that could be very costly to the bottom line, just not receiving forecasts reliably. So during the benchmark, there needs to be a way to fairly diagnose or keep track of how the forecasts are coming in reliably. And also, if different forecasters start at different times, but it's no fault of their own, that's where we recommend in the document that the sample should be normalized so that you have all forecasts for over the same period. So that is a consideration when you're executing the trial. And yeah, so this is actually during the benchmark. Let's go to the next slide, please, Gregor, if you flip to the evaluation phase. Yeah, and in this phase here, so you've accumulated all this data. You still are communicating frequently with the forecast providers to set the expectations like, hey, this is over now. We're going to do a summary report, and it's going to be at a certain time available. And also, the forecast providers should already know what are the criteria that they're going to be evaluated on. And in this case, we also want to make sure that all the metrics are calculated according to the plan. And it's really where you get to fill out a checklist, and that's why I put this little checklist picture here, where you can see, well, how easy was the forecast provider to work with? You know, it's a subjective. What about my objective metrics? And also, how about the reliability? You know, how often or how frequent were the forecasts coming in? You'd hope that 100% of the time. So really, this is the evaluation period after the main trial is over, and we will have that clearly documented in the larger draft. Let's go to the next slide, please. Okay, so these are real examples that the group that's contributing to the Work Package 2 IEA Task 36 has come up with actual trials where we've experienced all these pitfalls and best practices. So I kind of list them off here. And communication, it can't be overstated. So here, if we have inconsistent communication, I said that is a major pitfall which can really trip up smooth execution of a trial. So as I mentioned before, having the same communication to every participant, if questions come in, for example, everybody should get that question, not just the one who asked it, an answer to that question. Also, comparing forecasts from different time periods. This actually has happened to me in the past where I participated in a trial and forecast providers were each given a different wind farm to forecast for a 2-month period. And you can imagine how it's like putting your hand in a bag and picking the smallest, shortest stick. You know, you don't know. It's like rolling the dice, basically. It's comparing apples to oranges. So the best practice is making sure that your methodology and results are clear up front too, because then you can have the forecast provider even make recommendations on how to make it a fairer trial. Another pitfall to avoid is the poor design. As I mentioned previously, if you have too short of a trial, like during the summer, 1 month in the summer, that's not going to really be representative of what you're going to get over the year. So one of the best practices is at least 3 months, and you hope that that would span over a period where there's a lot of wind. But we also, in the document, will detail, you know, if you need to do a retrospective backcast, that can be done. There are advantages and disadvantages of doing that. But if you're, let's say, only have a month or two to carry out a trial and it's during the summer and you only need day-ahead forecast, it might make more sense to do something retrospectively. Lastly, I want to just highlight here that this has happened before where like incumbents are participating and they might have access to more data, so giving more data to one forecast provider than another. This can set up the case where there might be intentionally or unintentional cheating going on. Like to avoid that, make it fair to everybody, specify here's the data we're using, everybody's using the same data, has the same information, historical metadata, and being clear up front on the communication. That's really a common thread through all this that I really want to emphasize is the clear communication. With that, I would hand it over to John, who's up next here, talking about evaluation of forecast.
Yeah, and while I'm unmuting John, I'd like to have the little interjection here that we're actually already having a few questions on Slido. Here it's in this Slido code U719, where we will get to these questions afterwards. John, please.
Hey, thank you, Gregor, and hello, everybody. And I'll be talking about the evaluation of forecasts and forecast solutions. And as Jeff and Corinna have talked about, there are a number of factors that go into picking an optimal forecast solution. But one of the core factors is evaluating the performance. So which of the many solutions are going to provide the best performance for the user's application? It may sound like a simple question, but there are many issues. So the core part here is what we call forecast verification, which is really the practice of comparing forecasts to the available observations, which represent the actual conditions. So verification can serve a number of purposes. One is to assess the absolute forecast quality. So what are the absolute errors? And that may be relevant to a user. You know, how much error can I tolerate in my application? I want to know the absolute value of that error relative to what my expectations or needs are. But a second application of verification is to compare the quality of different forecasting solutions. So comparing A to B or A to B, C, and D, and try to determine which one will best meet the need. And finally, and not so much for benchmarks and trials, but verification can be an important part of a forecast improvement program to identify where the errors are and which ones are most significant and where the focus for forecast improvement efforts should be. But verification is a very complex topic. So it may sound simple, which of all the forecast solutions performs the best. But there are many, many ways, infinite number of ways to evaluate forecast performance. So they go from qualitative to quantitative. So, and we should remember that it is important to look at the verification from a very broad perspective. So qualitative approaches can provide important information. It can provide rapid identification of periods and patterns of poor performance, and also some types of systematic errors. It's just visually inspecting the forecast versus the available observations can tell you quite a bit, not quantitatively, but you can get a sense of how the forecasts perform in a qualitative sense. And then there are a number of ways to evaluate it more quantitatively, and a lot of it revolves around what we would call typical error metrics, like the mean absolute error, root mean square error. These represent the average error, but in many cases, that's not the most relevant to a forecaster's application or a user's application. So often we develop targeted error metrics that are designed to tell the user something about the error pattern relative to what's important to their application. And this is not done as often as it probably should be, but this can provide a lot more information than using the traditional metrics that tell us something about the average error. And we have to be careful about the type of metric we use and what incentive it might provide to the forecast provider to optimize performance for that metric. And is that really meaningful to the user? For example, a dichotomous evaluation, when we're looking at the yes or no for a specific event, and we look at, well, is the forecaster capturing that event? And if you just look at the hit rate, how many of the events are correctly forecasted, you can obviously score very high and you just forecast the event all the time. So you need to look at, say, the false alarm rate as well as the hit rate or the miss rate. So that's just a very simple example of how, if you don't have a comprehensive view of the evaluation process, you can generate very peculiar incentives to maximize performance on the metrics that you are using, and it may not be relevant to your actual application. So let's move on to the next slide. And a very important part of the verification is the significance of the results. And it all revolves around the fact that there is uncertainty in the evaluation process related to the metric that's used, the input data. So there's some period of time for which you're using data either real time or historically, and that data will influence the verification results. So you have to consider that there's uncertainty in the process of selecting what data you're using, and you're going to end up with perhaps different results if you select a different data set. And you have to look at the significance of the difference between forecast providers relative to the data set that you're using. And so if it's not representative, the results and comparison of performance may not be representative. And if the differences aren't significant relative to the variability or uncertainty, then there may essentially be no difference, even though the numbers may indicate some level of difference between one forecaster and another. So we need to keep that in mind when we evaluate forecasts and look at it from a number of different metrics and look at it from the point of view of how significant are the differences among the forecasters. So let's move on to the next slide here. And there's a difference between spill and value. So it's very important to realize that any measure doesn't guarantee that you're measuring the value to the user. So if we look at the difference between spill and value, spill is how well the forecast predicts the observed conditions according to some criteria or metric, right? So certainly we want to choose the correct metric or criteria for the purpose, the application. But you can have high spill and you're not measuring it properly, then it may not have any value, to the actual application. On the other hand, if a forecast performs well in terms of the metric that's important to the application, there may be value, but it may not have spill relative to other metrics, like mean absolute error. May be higher than another forecaster, but it may perform well in a different perspective, a different metric, different way of evaluating, and that may have much more value to the application. So we need to keep in mind when we do the evaluation, spill and value are not the same thing. You can measure spill in different ways, you can measure value in different ways, and ultimately we're looking for a solution that maximizes spill and value, but still relative to the purpose that you're intending to use the forecast. So there's two parts to the assessment process. Let's move on to the next slide. And to give you an example here, I'm going to talk about a forecast solution for the Hawaii Electric Light Company on the Big Island of Hawaii, referred to as HELCO. And they have a system with about 90 to 180 megawatts of net load from minimum to maximum, from morning to evening. And fairly high penetration of renewable energy and wind capacity, 31 megawatts split between two wind farms on the northern southern tip of the island, and a solar capacity pretty much all behind the meter distributed of about 90 megawatts. So you can see the penetration level of wind and solar is quite high. So they have to deal with the variability. They're on an island grid system. There's no interconnections. So you can't call for help. You have to deal with the variability with the resources you have available. And when we evaluated the key decision times, we determined there are three of them. 5 a.m., 10 a.m., and 1 p.m. in the afternoon, local time. I'm going to focus on the 0500 time here, which is the preparation for the morning net load peak, which occurs about 7 or 8 a.m. as people get up and get ready to leave their homes for the day, and the midday minimum, in which you get a lot of distributed solar and the net load drops off after the morning peak. And there's two issues that come up when you're making decisions at 0500 in the morning for the morning peak and the midday minimum period. And the first is, will the midday net loads be low enough to shut down a unit after the morning peak? And you can see there's some different decisions that are made depending how that question is answered. And the second question is, will an excess energy situation occur to the high as available renewable generation? So if you're going to have excess energy, do you curtail the renewables, or do you take a non-renewable unit offline? And how do you decide what the best solution is? So when we move on to the next slide, we'll see that the forecasts are an important part of determining what type of renewable energy generation you'll have during that mid to late morning period. And so the 5 a.m. forecast, if you evaluate the wind forecast over the next 6 hours to 11 a.m., so through the mid and late morning period, you'll see the mean absolute error is about 9%, and that's about 32% lower than persistence forecast, and lower than climatology adjusted persistence forecast as well. So that's actually pretty close to state-of-the-art performance. So you say, well, this must be a valuable forecast. We're getting pretty good performance considering that we have 2 wind farms on the system. So fairly concentrated wind production with a lot of variability. So 9% is actually pretty good for that type of situation. But what does it really tell us about the value to the 5 a.m. decision-making process? So let's move on to the next slide. And on that slide, we can see that the important question from a wind point of view is, will the wind significantly increase or decrease from 5 a.m.? So we know what we have. So the operators look and say, I know what the wind's producing now. Is it going to go up or down a lot? And the same thing with solar. Am I going to have a typical day, or is it going to be much higher or lower than what I typically get in that midday period? So from wind point of view, the question here is not the mean absolute error. And most of the time, the wind doesn't change that much from 5 a.m. to the middle of the day. The trade winds in Hawaii are actually quite persistent. And you can, on many days, just sit back and say, when I have a 5 a.m., I'm going to have right through the middle of the day. But yeah, there are a fraction of days where it changes quite a bit. And that's what we want to know. So we defined an event here as the top 10% and bottom 10% of the daily change from 5 a.m. to that 8 a.m. to 11 a.m. late morning period. And the chart on the right here shows the forecasted and actual changes from 5 a.m. to the late morning average production. And you can see most of that is in that middle range where you have 0 actual change and 0 forecasted change. So forecast most of the time, remember on the chart here, every point is a day in 2017. So we're looking at the changes for every day. And most of the time, the forecast system says not much change, and what happens is not much change. So we do really well, and hence we get a low MAE out of that. But you'll note that there are a number of changes that are in the tails, the top 10% and bottom 10%. And those are the points above the green line in the vertical and below the green line. And the forecast extreme events are to the right and left there. And so if you forecast the extreme events correctly, you should have points in the upper right box number 9 and lower left box number 1. So those are the events that we're interested in. And we'll see the forecast system, even though it has a good MAE, will tend to forecast typical conditions much more than they actually are. So it doesn't differentiate well the tail events from the typical events, which is what the operator really wants to know. That's what the value is in the 5 a.m. decision-making process, is how well can we differentiate the atypical, unusual bit changes from the typical events. And the mean absolute error is measuring the typical events. So if we look at the critical success index, the CSI, which is basically a ratio of the hits to the forecast and the observed events, right? And so 100% meaning we have all hits, 0 you have no hits. And you can see that the score there for the up and down changes, right, which is box number 9 and box number 1 on the scatter plot there, you only get about 5% of the events correctly forecasted. So that is not very good performance for the decision making. But remember, these events are relatively unusual, don't happen much, so have very little impact on the mean absolute error. So it shows that if you focus on the wrong metric, you can get an impression that's very different on the value to your solution. And here, by analyzing the appropriate decision-making process and what information you needed for that, you can come to a better way of evaluating forecast performance. So let's go on to the next slide, which summarizes what we get from this example. So the key points here that the key operating decisions and timeframes were identified. When is forecast input most important and how is it important to the decision-making process? And then we developed a customized categorical forecast evaluation scheme. And categorical schemes are often the most relevant to decision making because humans tend to think in terms of categories. Is this a big change I have to consider, or is just a typical day, right? And so those types of things are better evaluated for the categorical perspective than a continuous metric like MAE, which tends to focus on typical conditions. And then finally, the categorical performance was measured with a specially customized metric for that purpose. So the point is that traditional metrics here, we had state-of-the-art performance, but the customized metrics and category-based approach indicated that we're missing still in forecasting the very important atypical conditions. So, and this is because the forecast system was designed to minimize the MAE, the average error. So by repositioning the optimization process, we can get a forecast that is more relevant to the user. So let's move on to the next slide. So the important considerations here are that verification is subjective, right? So you look at what Corinna, Jeff, and I pointed out here, that there's an uncertainty in the whole process. So it's subjective, and how you design it and what data you use determines where the uncertainty is. So you need to consider there is uncertainty, and you need to look at a different set of evaluation metrics depending on your application. So you really should measure a range of forecast performance attributes, not just one, especially those if you can identify them that are relevant to the user's application. So ideally, a cost function, that's the last point there, should be used, but many times it's hard to develop a customized cost function. So a matrix of evaluation metrics can approximate a cost function. So that might be an alternative solution. So overall, if you look at benchmarks, what is the key to getting the most meaningful results from a benchmarking process? And as Jeff mentioned earlier, it's representativeness. Make sure you have a representative sample that you're using. Results are significant, and repeatability is important, so that if you pick forecaster A, that should be a consistent outcome. It shouldn't vary from one data period to another. Fairness, meaning that you're providing the same information and you're ensuring that the evaluation process is the same and there isn't too many opportunities for cheating. And transparency, so that the forecast providers can understand how the forecasts were evaluated, how the data was quality controlled. So all those things will ensure a meaningful outcome. If you don't pay attention to any of those factors, there's a risk that the results may not be meaningful. So let's move on to the final slide here that I have. And so this summarizes the key factors for effective forecasting solution. As Corinna mentioned, there should be a decision support tool to organize the solution formulation process. And then the next step is in the benchmarking, we want to have a representative, transparent, and fair test with good user-provided communication. And finally, the evaluation should be designed to be relevant to the application. So a cost function ideally, but certainly an evaluation metrics of different scores according to their importance to the application. So we go on to the final wrap-up slide here. We'll open it up to questions. There's information on the project webpage about the documents, and all of us are available to be contacted by email if you have any questions after the seminar.
Thank you to all three speakers. We're actually nearly out of time, but I think those questions that I've seen here are mostly relatively quick to answer. The first one is from Laurent and asks, is there a corresponding summary report? And I'll take that because yes, we're working on it. And once it's public, it's definitely going to be distributed through the mailing list on the website and through all sorts of other channels of communication. And to that, I also take the question, has there been a validated package that has been developed under the task? And no, there isn't, not yet, but the forecasting task has just ended its first, or it's just about to end its first phase. And for the second phase, we actually put that into the work program to look into it. There is something already in the wind bench task, and there are some other packages available. So we have to see what we actually can use and how much there is. There have been some parts of it developed in some areas, but we want to unify that and put out one eventually. Then, why don't you have, Henrik, which I presume is Henrik Massen, asks, why don't you have, why can't you have probabilistic forecasting in the multi-vendor case? And that depends on how you represent the forecasts. I'd like Corinna to answer that one.
Yes, I think it's very much dependent on what the application is and what the uncertainty or the probabilistic forecast, how that looks. What I refer to is that sometimes probabilistic forecasts are considered when you have a number of deterministic forecasts and that they don't represent the uncertainty. That's one thing, because they are by themselves dampened and they don't, they will normally not provide extremes. What I also refer to when I say it's it can of course be done, but if you aggregate uncertainty, for example, you need to have the individual members in from ensemble forecast, or I don't know how you do this with statistical methodologies. So this is one of the issues that I refer to. And of course, there will be applications where you can have multiple vendors and that provide probabilistic solutions that that will work. But it's a longer discussion, I guess. But when I say it's difficult, I shouldn't have said it's impossible. It's difficult in many of the typical applications. I hope that answers the question.
Thanks. Let's go to the next question. Are the results replicable for PV forecasts? And I think I'll give that to John.
Let's see. Yeah, well, the results are replicable with the same issues for PV forecasts as for wind forecasts. That you have to ensure that you have a representative period, and there's going to be uncertainty in any type of forecast. And so you need to look at the modes of variability, the weather regimes that are specific to the solar resource in that case. So certainly there are times a year we have low wind variability, high wind variability, and same thing with solar, that you may have, depending on the location, there's different times a year when there's almost no solar variability. California, desert areas in the summer. So if you evaluate a forecast there, you're going to get the same profile almost every day. And so that's not going to be a very good evaluation. So if you look at that, you look at a different location, things may not be replicable at all, because the variability which differentiates forecast performance more won't be there. So you need to look at the issues that relate to uncertainty, as the replicability is related to properly evaluating the uncertainty in the forecast evaluation.
Okay, thanks. And then we have the question to your talk, Jeff. The incumbents versus prospective providers, are they going to have the same amount of data available? And will you usually, as a new provider, get the historical data set to train the model?
Hi. Yes. So this is actually very could be controversial, just because if a provider has making forecasts for a wind farm or for a company for a long time, is the company going to provide that in a trial to all the data to the new forecast providers in the trial? Probably not, especially you're talking about turbine data. It depends on the type of data that in the history, the length of the history, but most likely not. What we like to do is in the best practices, at least say like, hey, this should be the minimum if you're over this many years old, the wind plant. Because yes, you could get into a situation where the wind plant could be operating for 5 years or more, and are you really going to provide everything to all the forecast providers? Perhaps, but that could be a lot of data. So that's a great question. I don't have a clean-cut yes or no answer. It really depends on the situation.
Okay. And there's a voice mentioning our website, where the 2018 wind integration workshop papers that will be appearing anytime soon on the website. And from there you also can access the YouTube video of these webinars for, if you have any colleagues who are interested, IEA Wind Forecasting.dk. And there we'll also provide the final report and the IEA recommended practice once it's done. So with that, I'd like to thank again my speakers, Corinna, Jeff, and John. And next week at 4 o'clock, so 1 hour earlier than today, we're going to have a webinar on probabilistic forecasting in practice, which is essentially based on a couple of articles that we did in the task. And the week after, again at 1700 Copenhagen, there will be how to run 40% plus wind in the Danish system by Lasse Borup from Energinet, the Danish TSO, and I'm looking forward to that one too. So with that, have a nice evening, have a nice day, or have a good night, depending on where you are, and talk to you again next time. Bye-bye.